So to conclude and give you some final comments about bootstrapping and its implementation are we can use bootstrapping for a number of different things, but the primary reason here that we were using it was because we had small sample sizes. Now, we could also do this when we may think that we have our assumptions of normality or constant variance violated, right? So we can resample different parts of the smaller sample, right? Now, again, the problem here is that we still must assume that the sample that we are bootstrapping from is representative of the overall population. And this is going to become a more effective strategy, right, as you incorporate larger samples. So you have a larger N, right? And that makes sense because you are reducing, right, the variance within each of those subsamples. Now, there is some bias correction that we could do for bootstrapping, but we're not going to have a chance to get into that in this class. And you can also use the distribution, right, of the bootstrap estimates to calculate a bootstrap estimate of the standard error. So bootstraps on bootstraps. Now, I'm again going to warn you against doing that because you're going to have to assume, right, that the sample that you are bootstrapping from is representative of the population. Now, to conclude, to remind you, what are the steps of bootstrapping? Well, one, right, we're interested in making an inference about some population parameter, be it a mean or some relationship between two variables, right? And we have some estimate of that. Now, we might have a sample mean that would be an estimator of a true underlying population mean, or we might have some estimated coefficient of the relationship between some x and some y, right? Now, we do have, again, this is an assumption, that we have a representative sample of observations, maybe 1,000 observations, like 1,000 patients, and that's coming from a representative sample of a population. So we need to assume if we have 1,000 undergraduates that those undergraduates are representative of the population we're making an inference to. So maybe all undergraduates in Emory. Now we're gonna again resample with replacement. So after each bootstrapping round, we will put the observations back into the sample. So they could be potentially chosen in subsequent following samples, right? And we're going to do that for a set number of samples. So in our instance, we did 1,000, right? And so this is going to give us a sampling distribution of that correlation coefficient or that estimated coefficient of the relationship between x and y. And we're going to repeat that, right, for a certain subset. And the final step there is that we can actually estimate, right, get hopefully a valid estimate of either the true relationship between, in our example, reported weight and actual weight from the sampling distribution from our bootstraps. This concludes our lesson on bootstrapping and resampling.